All right, here's your video on writing up your lab report for the Momentum Lab. All right, so our goal here was we used low friction tracks. We tried to get our time intervals down so that that force of friction wasn't very effective at changing the momentum. So our hope is that momentum was conserved. Hopefully there was no net external forces or they were of negligible size. So what we're going for is we want to see, does the momentum before the collision equal the momentum after the collision? We are going to solve that for both our perfectly inelastic situation and our elastic or inelastic situation. We're not sure which one it is. We will find that out when we do the kinetic energy loss. All right, so we're trying to figure out if these two sides are equal. So we want to say how different are they? So we're going to use a percent difference there. And so we're going to look at the momentum afterwards minus the momentum before. Take the absolute value if you need to. It probably will come out to be a negative number here, so you might need that absolute value. And then divide it by the average of those two numbers times 100 to get that percent difference. You should be getting percent differences if you're taking good data of about a 1% loss on perfectly inelastic and something a bit more for the elastic inelastic problem. And when you get to your results conclusion section, you are going to want to discuss, why do I expect these to be different? Why is there that difference there? Okay. If you are not getting numbers in here, one thing to check for is check to make sure that you got that one direction of one of the velocities flipped. So for instance, I gave you the hint, every time you do this, take the red cart and flip the direction of its velocity so that when they're moving toward each other, it's not a positive velocity and a positive velocity, it's a positive velocity and a negative velocity. Okay, so that's our first check, and you're going to do that for both of those types. We're also going to want to look at how much energy was lost in this elastic inelastic collision. And the reason we want to look at that is if it comes out to zero, we have ourselves an elastic collision, meaning there was no sound, heat, deformation, any of that stuff. If it's negative, that means we lost some energy. We have an inelastic collision where they start apart, end apart. Okay, so we do our percent energy loss. This should come out to be a decent sized number. I'm seeing things like 40% typically. Some will be less, maybe like 20, some will be more like 60. But again, it'll be a larger number than you're getting over here. Okay, it will be negative too, and that negative is important, and make sure you discuss why it's negative and why it's probably so big. Where did that energy go? Recoil is a little different. So for the recoil portion, we're trying to, again, see if that equal sign is true, but it's really hard to compare with zero. So how we're going to do this is, because we think it's going to be zero, we know that these two numbers, one of them is going to be positive, one of them is going to be negative, but they should be the same magnitude. So what we're going to do is we're going to compare the magnitude of those two. So as you see, there are a lot of absolute value signs here to keep in mind. So we're going to take the absolute value of the momentum of 1, the absolute value of the momentum of 2, take the difference, take the absolute value again, and divide it by the average of those absolute valued momentums to figure out the percent difference. This one, probably around the 2% range I'm seeing from students as they're doing this recoil one. Again, we're going to want to discuss why we're seeing these percentages. Even though they're small, why are they showing up? So what's going on there? You're going to want to discuss that in that conclusion section. So there is your lab write-up kind of video to walk you through that. Again, if you turn it in early, get it in early for feedback, I'll give you that feedback. You make corrections, turn it back in again. All right, go to it.